This is Activity 2, Solutions in the Coordinate Plane for Lesson 13, More Solutions to Linear Equations. And keep in mind as we go through this activity that you have coordinates to a point. So here's a point, and here are the coordinates to that point, an x-coordinate and a y-coordinate. And the coordinates define where that point is placed in the coordinate plane. And those coordinates, the x-coordinate and the y-coordinate, are solutions to the equation for this line. So this line is defined by an equation. And if you take the coordinates, the x and y coordinates, and put them into this equation, it will make the equation true. So we say that they are a solution to this equation. And so here is the line defined by the equation. So you have a point that when the coordinates to that point are placed into the equation, it makes the equation true. That's called a solution to the equation, and that equation defines a line in the coordinate plane. So this is tough, and so I'm going to go over this in several different ways. Here's some writing that hopefully helps understand it. And so at the bottom, I think this is the most important thing to focus on. You have coordinates of a point that are solutions to the equation for a line, making the equation true. So once again, coordinates, a point, the coordinates are solutions to the equation, and that equation defines a line in a coordinate plane. So you have equations for line, coordinate plane, so you have an x-coordinate and a y-coordinate. Those two coordinates together define the placement of this point in that grid, in that coordinate plane, and that point is on a line. That line is defined by an equation, and if you take the x-coordinate and the y-coordinate and put them into that equation, it will make that equation true. And so the graph of the equation is the line drawn in the coordinate plane. So again, the coordinates of a point, so you're going to be given this image, and so the coordinates of a point, the x-coordinate and the y-coordinate, x and y, are the solution for the equation for a line. So you have a bunch of lines, 3 lines. Each of those lines have an equation. So if you take a point on those lines and use the x-coordinate and the y-coordinate for that point, put them into the equation, they will make the equation true because it is a point on this line. And the equation defines that line. So you have 3 lines, L, M, and N, 7 points. And so each of these 7 points, most of them are on a line. I think it's just point J here. That's not on any of the 3 lines. So I'm going to go through each of these comments. You're supposed to decide whether or not they are true or false. And so I'm going to go through each one of them in this way. So this is comment number 1. So here's the grid, and it says 0.40 is, actually it says in the activity, 0.40 is a solution for the equation for line M. So here's line M, but here's 0.40 right here. So it's 4 along the x-axis and 0 along the y-axis. Well, that point is not on this line. So it is not a solution for the equation. If you took these coordinates, the x-coordinate of 4 and the y-coordinate of 0, and you put them into the equation for this line, it will not work because 0.40 is not on this line. Number 2, the coordinates for point G, so here's point G, makes both the equations for lines M and N true. And that is true because point G is on line M, so the coordinates for point G will make the equation for line M true, and point G is also on line N, so the coordinates for point G will make line N, the equation for line N, true. Number 3, it says x equals 0 is a solution for the equation for line N. So here's line N, and you might think this is true because it goes through the origin in which x is 0. But remember, when x is 0, y can be anything. So y can go up and down the y-axis. while x is 0. So in order for it to be a solution to the equation, you also need a value for y. So this has to be stated as x equals 0 and y equals 0. You need both of those coordinates to have a solution for the equation. But because they only give you one of them, it is not a solution to the equation. You need both. Number 4, 0.20. 0.20 is right here. Makes both the equations for lines m and n true. Well, no, it doesn't. Actually, it makes neither one true because 0.20, which is point J here, is not on either line m, nor is it on line n. So it makes neither of those equations true. Number 5, no solution for the equation for line L that has y equals 0. So here's line L, and they're saying because it doesn't cross the x-axis, and when it crosses the x-axis, y is equal to 0. It's not going up or down. Because it doesn't cross the x-axis, they're saying there's no solution where y equals 0. But that's not true. That's false, because all you have to do is extend these lines out farther. So extend the x-axis out farther and extend line L out farther until they do intersect. And at that point, it looks like it's about 0.80. So you go, this is 6, 7's about right there, 8's about right there. So 8 and the y coordinate is 0, so it's 0.80. And that would be a solution to the equation for line L. So all you have to do is extend them until they intersect. Number 6, the coordinates of h is right here, is a solution to the equation for line L. So here's line L, and that's true because h is on line L. The coordinates for h will be a solution for the equation for line L. So that's true. 7, there are only 2 solutions for the equation for line L. And I think what they want you to look at is point H right here, and actually this intersection right here, and think, oh yeah, there's only 2 solutions. But in fact, there's an infinite number of solutions. So remember that a line is made up of an infinite number of points. Every coordinate, x and y coordinate for every point on that line is a solution to the equation for that line. They will all work in the equation to make the equation true. So there are an infinite number of solutions. It's all the points. There are an infinite number of points on the line, so there are an infinite number of solutions to the equation. They are all points on that line. Number 8, there's a point that makes the equations of all 3 lines true. Well, that's false. There's no place where there's no single point where all 3 lines intersect. But if I move this line, you can move any of the lines, but if I move this line up to G, so slide up here, so that would make point G, the coordinates for point G, a solution for the equation for M, N, and this new line right here. So all 3 lines could use the coordinates for point G, and they would all be solutions to their equations. So remember, we're talking about coordinates, x and y coordinate. We're talking about the point that's defined by those coordinates. If you take those coordinates and put them into the equation, they will make the equation true. So they're known as solutions to the equation, and you have an equation for the line. So that's right here. So this equation defines this line. So coordinates, points, solutions, equation, and line.